I want to welcome you to the lecture for section 7.5. This is Mac 2233 Applied Calculus, and my name is Jorge Young. So the objective for section 7.5, which is the last section in the course, is we're going to find the area between two curves. So we're going to understand how we can use integrals to find the area between two curves. Then we're going to go ahead and find the consumer surplus and also find the producer surplus. So the first thing here is we have three images. We have A, B, and C. The second one, B, shows the function f of x, and it shows the area underneath the curve f of x from A to B above the positive x-axis, or above the x-axis, if you will. So that's the area. Now we have g of x, and again we can see the same thing there. So we can actually find the area between these two curves, and that's going to be A using integrals, and essentially that's the area between two curves. So we can actually find this by finding the integral, which will be the difference between f of x and g of x. So the next slide here that we have, so let's say f and g are continuous functions, and suppose that f of x is greater than or equal to g of x over the interval a, b. Then the area of the region between the two curves from x, when x equals a, to x equals b is given by the integral from a to b of f of x minus g of x of dx. So the difference, so the integral of the difference of the two functions will give us the area between those two functions between a and b. So here we have an example. So we have two functions. F of x is 2x plus 1 and g of x is x squared plus 1. So the first thing we're going to do is we're going to look at the graph of these two functions, and then we're going to determine whether they intersect. So there's two ways that we can do this. If you have the capabilities to graph them and actually calculate the point of intersection, then that might be easier or faster to do. So here, looking at this graph, we can see that f of x and g of x intersect when x equals 1 and when x equals 2. So those are the 2 points of intersection. Now, to do this algebraically, we can go ahead and actually set them equal to each other. So 2x plus 1 is equal to x squared plus 1. We solve for x and we get that x equals 0 or x equals 2, which is the same thing that we saw here in the image from the previous slide. So now the next thing that we're going to do is we're going to go ahead and compute the integral. So, and again, this integral will be the area between these two curves. So now note that between 0, when x is between the points 0 and 2, f of x is actually above g of x, which means that when we calculate the integral, we're going to do f of x minus g of x. So here we have the integral. Again, f of x was 2x plus 1, g of x was x squared plus 1. So from 0 to 2, we're going to go ahead and calculate this integral. So here we just simplify that, so it becomes the integral of between 0 and 2 of 2x minus x squared dx. That turns out to be x squared minus x cubed over 3 from 0 to 2. We calculate this the way we've done in the previous example, and we get that the area between these two curves is 4/3. And again, so A in the area, so this golden area right here is equal to 4/3. So this is the area between f of x, which is 2x plus 1, and g of x, which is x squared plus 1. So the next thing that we're going to talk about is consumer surplus and producer surplus. So here we have the supply function and demand function, and the equilibrium point, xe and pe, is the point at which the supply and demand curves intersect. So this is the point at which sellers and buyers come together and purchases and sales can actually occur. So if you notice, we have two other sections that are shaded. The goldish orangey one is consumer surplus, and the green one is producer surplus. So we're going to find out how we can calculate these two values or quantities, if you will. So the first thing is, let's suppose that P equals D of X describes the demand function for a certain commodity. Then the consumer surplus is defined for the point QP, such as the integral from 0 to q of d of x dx minus the product of qp. So what we do, and the reason why we minus is because the demand function is actually above the area that we're trying to find out. So we're going to do the integral of this function minus the product of qp. And if you notice, the minus the product of qp is just going to be the area of this rectangle right here. So, for example, find the consumer surplus for the demand function that's given by d of x is equal to x minus 5 squared when x equals 3. So when x equals 3, or d of 3 is actually equal to 4. So we have our points. So x is 3 and if you will, your Y is 4, or your PE, your price is $4, and your quantity is 3. So the consumer surplus then will be the integral from 0 to the point XE, which in this case will be 3, of dx of d of x dx, minus the product of XE times PE. So again, the function d of x is x minus 5 squared, so we go ahead and substitute that in there. 3 times 4 is 12. So we're going to find then the integral from 0 to 3 of x squared minus 10x plus 25 dx minus 12. And here we have all of the steps. So we find out that that actual value that we found out, the consumer surplus, is actually $27. So going back, this area right here is $27, or is equivalent to $27. Now the next thing is we're going to go ahead and find the producer surplus. Now suppose that P is equal to S of X as the supply function for a commodity. Then the producer surplus is defined for the point QP as being the product of QP minus the integral from 0 to Q of the supply function dx. So again, the reason being is because the actual rectangle QP, part of it is above the supply function. So therefore we want to find the area underneath the curve, which is this yellowish right here, and then we want to eliminate or subtract from the main area here of this rectangle from this green part from the gold part. So we're going to go ahead and find the producer surplus. So S of X is equal to x squared plus x plus 3 when x equals 3. So we're going to find y when x equals 3. In other words, we're going to find P of E when x of E equals 3. So when x equals 3, S of 3 is 15. Then the producer surplus would be XE times PE minus the integral from 0 to XE of S of X dx. So 3 times 15 minus the integral of x squared plus x plus 3 from 0 to 3. So doing all of the algebra, we get that it's equal to $22.50. So here's another example. Given that the demand function is x minus 5 squared and supply function is x squared plus x plus 3, find each of the following. We're going to find the equilibrium point. That means the point where these two functions intersect. We're going to find the consumer surplus at the equilibrium point and the producer surplus at the equilibrium point. So the first thing that we're going to do is we're going to find the equilibrium point. So we're going to set d of x equal to s of x and solve. So here we get that x equals 2. So x of e, or the quantity at equilibrium, equals 2. To find the price, we're just going to go ahead and substitute this value into either the demand function or the supply function, and we're going to go ahead and solve. So using the demand function, we get that the price is $9. So the point of the equilibrium point then is quantity is 2 and the price is $9. So that's part A. Part B is the consumer surplus. So the consumer surplus, again, is going to be the integral of the demand function minus the product of the equilibrium point and the price. So it's going to be the integral from 0 to 2 of x minus 5 squared dx minus 2 times 9. And then we end up with $14.67. So that's the consumer surplus. Now the producer surplus is just going to be XE times PE minus the integral of the supply function. So here we get that it's going to be 18 minus the integral from 0 to 2 of x squared plus x plus 3 dx. We do all the algebra and we get that it's approximately $7.33. So we found out how to find the equilibrium point, consumer surplus, and producer surplus, and also find the area between two curves. And that's the end of section 7.5. My name is Jorge Young. Thank you.